Welcome to the WWC RDD Standards training module focused on functional form and bandwidth. You can access all the resources mentioned in this module through the WWC website, whatworks.ed.gov. This module describes the WWC's fourth RDD standard, referred to as the Functional Form and Bandwidth Standard. It outlines requirements for RDDs to document the appropriate specification and application of functional form and bandwidths used in the design. This module introduces the concepts of functional form and bandwidth and then describes how the WWC assesses these issues in RDD studies. After completing this module, you will be able to define why the WWC is concerned about functional form and bandwidth specification in RDDs. You will be able to describe the WWC's functional form and bandwidth standard, and will know how to apply that standard when conducting a WWC review of an RDD study. The WWC's fourth RDD standard focuses on the appropriateness of the functional form and/or bandwidth specification used in an RDD study. The WWC is concerned about functional form and bandwidth specification because unlike in randomized control trials, in an RDD, statistical modeling plays a critically important role in estimating intervention impacts. As described in previous modules in this training series, estimating credible intervention impacts from an RDD study requires some sort of regression adjustment for the forcing variable in the impact analysis. As discussed in Module 2, two modeling approaches that are commonly used to reduce misspecification bias are local regression and global polynomial regression. Misspecification in these regressions can lead to a bias in impact estimation. For example, if a linear functional form was specified for the impact analysis, when in fact the true relationship was quadratic or nonlinear in some other way. Thus, two of the most critical aspects of statistical modeling in RDDs are the functional form specification of the outcome forcing variable relationship and the bandwidth, or the range of the forcing variable values used to select the analytic sample. Criterion D of the functional form and bandwidth standard requires that findings be robust to varying functional form and bandwidth choices, depending on the type of analysis approach that is used in the design. Criterion D is complicated, so you may wish to pause or rewind the video to ensure that you understand it. Let us first consider those scenarios where Criterion B is met, when the impacts in the RDD are estimated using local linear or nonlinear regression, or a related nonparametric approach, in which impacts are only estimated within a justified bandwidth. Again, this is generally the preferred analytic approach because it better ensures an appropriate functional form specification of the outcome forcing variable relationship. In this scenario, when Criterion B is met, a study can satisfy Criterion D in one of two ways. First, if findings from robustness checks demonstrate that the sign and significance of impact estimates is the same for a total of at least two justified bandwidths. Two impacts are considered to have the same significance if they are both statistically significant at the 5% significance level, or if neither of them is statistically significant at the 5% significance level. Two impacts are considered to have the same sign if they are both positive or both negative, or if one is positive and one is negative, but neither are statistically significant at the 5% significance level. For example, if the sign and significance of an impact are the same using a bandwidth selected by cross-validation and a bandwidth selected by the IK plugin procedure, then a study would satisfy Criterion D. If a study satisfies Criterion B, the other way that a study can satisfy Criterion D is if the sign and significance of impact estimates is the same for at least one justified bandwidth and two additional bandwidths that are not justified. As we've discussed, some studies may not estimate intervention impacts within a justified bandwidth, but may instead use best fit regression modeling approaches, such as global polynomial regression approaches, or they may use some other local approach with an unjustified bandwidth. If the study fails to satisfy Criterion B, then it is not necessary to consider the robustness requirement. The robustness requirement only applies to studies which may fully satisfy the functional form and bandwidth requirement. To partially satisfy the bandwidth requirement, studies may satisfy criterion C, but need not satisfy criterion D. However, some studies might present both a local or non-parametric approach with a justified bandwidth alongside a best fit global polynomial regression and satisfy both of criterion B and C. In those cases, 3 additional options are available. First, the study could satisfy criterion D if the sign and significance of impact estimates is the same, using a total of at least 2 different goodness of fit measures to select functional form. For example, this criterion would be satisfied if the impact corresponding to the functional form selected using the AIC goodness of fit measure is the same sign and significance of an impact corresponding to the functional form selected using R squared. The second way a study satisfying criterion C can also satisfy criterion D is if the sign and significance of impact estimates is the same for at least 3 different functional forms, including the best fit regression. Finally, a study could satisfy criterion D if the authors show the same sign and significance for the impact estimated within a justified bandwidth and the impact estimated using the best fit regression. In the case where a study attempts to demonstrate multiple forms of robustness, the study meets criterion D so long as one form of robustness check meets the WWC's requirements. For instance, imagine the authors from a study that satisfied criterion B demonstrated the effect was positive and significant for 2 estimates using a justified bandwidth, but an estimate from an unjustified bandwidth was negative and non-significant. This study would meet the requirements of option 1 for satisfying criterion D when criterion B was met, even though it would not meet the requirements for option 2. In this case, the WWC would still consider this study robust to varying functional forms of bandwidths, given that it satisfied option 1 for meeting criterion D. Criteria A of the functional form and bandwidth standard requires that the local average treatment effect for the outcome must be estimated using a statistical model that controls for the forcing variable. In an RDD, it is never acceptable to estimate an intervention impact by simply comparing the mean outcomes for an intervention comparison group without adjusting for the forcing variable, even if there's only a weak relationship between the outcome and the forcing variable. Criterion B of the functional form and bandwidth standard requires that the study use a local regression or a related non-parametric approach, where impacts are estimated within a justified bandwidth. The WWC defines a justified bandwidth as one that was selected using a systematic procedure that is described and supported in the peer-reviewed methodological literature. Some of the most frequently used procedures are bandwidth selection via cross-validation, the plug-in or in-bends Kalyanaraman procedure, or the Kalinoko-Cataneo and Tatunic procedure, also known as the robust CCT. Other bandwidth selection procedures are justified if they are described and supported in the methodological literature. For instance, a procedure would be considered justified if it were described in a peer-reviewed journal that describes its procedure and demonstrates its effectiveness in a broad way. In contrast, any bandwidth selection procedure without methodological support would be considered to yield an unjustified bandwidth. For instance, if a bandwidth procedure were simply described in an applied journal article that happens to use the procedure, but the article itself did not empirically demonstrate its effectiveness. For studies that do not use a local regression or related non-parametric approach to justified bandwidth, criterion C of this standard allows for less ideal approaches. These approaches estimate impacts using a best fit regression using either the full sample or a sample within a bandwidth that need not be justified. To satisfy criterion C, the functional form of the outcome forcing variable relationship must be shown to be a better fit to the data than at least 2 other functional forms. For instance, the authors might compare a linear functional form to a quadratic or cubic form. Any measure of goodness of fit from the methodological literature can be used for this purpose, such as the Akiaki Information Criterion, or AIC, the Bayesian Information Criterion, or BIC, or other fit statistics, such as an adjusted R-squared. Criterion D of the functional form and bandwidth standard requires that findings be robust to varying functional form and bandwidth choices, depending on the type of analysis approach that is used in the design. Criterion D is complicated, so you may wish to pause or rewind the video to ensure that you understand it. Let us first consider those scenarios where criterion B is met, when the impacts in the RDD are estimated using local linear or nonlinear regression, or a related non-parametric approach in which impacts are only estimated within a justified bandwidth. Again, this is generally the preferred analytic approach because it better ensures an appropriate functional form specification of the outcome forcing variable relationship. In this scenario, when criterion B is met, a study can satisfy criterion D in one of two ways. First, if findings from robustness checks demonstrate that the sign and significance of impact estimates is the same for a total of at least two justified bandwidths. Two impacts are considered to have the same significance if they are both statistically significant at the 5% significance level, or if neither of them is statistically significant at the 5% significance level. Two impacts are considered to have the same sign if they are both positive or both negative, or if one is positive and one is negative, but neither are statistically significant at the 5% significance level. For example, if the sign and significance of an impact are the same using a bandwidth selected by cross-validation and a bandwidth selected by the IK plugin procedure, then a study would satisfy criterion D. If a study satisfies criterion B, the other way that a study can satisfy criterion D is if the sign and significance of impact estimates is the same for at least one justified bandwidth and two additional bandwidths that are not justified. As we have discussed, some studies may not estimate intervention impacts within a justified bandwidth, but may instead use best fit regression modeling approaches, such as global polynomial regression approaches, or they may use some other local approach with an unjustified bandwidth. If the study fails to satisfy criterion B, then it is not necessary to consider the robustness requirement. The robustness requirement only applies to studies which may fully satisfy the functional form and bandwidth requirement. To partially satisfy the bandwidth requirement, studies may satisfy criterion C, but need not satisfy criterion D. However, some studies might present both a local or non-parametric approach with a justified bandwidth alongside a best fit global polynomial regression and satisfy both of criterion B and C. In those cases, three additional options are available. First, the study could satisfy criterion D if the sign and significance of impact estimates is the same, using a total of at least two different goodness of fit measures to select functional form. For example, this criterion would be satisfied if the impact corresponding to the functional form selected using the AIC goodness of fit measure is the same sign and significance of an impact corresponding to the functional form selected using R squared. The second way a study satisfying criterion C can also satisfy criterion D is if the sign and significance of impact estimates is the same for at least three different functional forms, including the best fit regression. Finally, a study could satisfy criterion D if the authors show the same sign and significance for the impact estimated within a justified bandwidth and the impact estimated using the best fit regression. In the case where a study attempts to demonstrate multiple forms of robustness, the study meets criterion D so long as one form of robustness check meets the WWC's requirements. For instance, imagine the authors from a study that satisfied criterion B demonstrated the effect was positive and significant for two estimates using a justified bandwidth, but an estimate from an unjustified bandwidth was negative and non-significant. This study would meet the requirements of option 1 for satisfying criterion D when criterion B was met, even though it would not meet the requirements for option 2. In this case, the WWC would still consider this study robust to varying functional forms of bandwidths, given that it satisfied option 1 for meeting criterion D. Criterion E of the functional form and bandwidth standard requires that a study include a graphical analysis displaying the outcome forcing variable relationship. The graphical display should not be obviously inconsistent with the choice of bandwidth and the functional form specification used for the impact analysis. The graphical analysis must include a scatter plot and a fitted curve, where the scatter plot can present raw data or data averaged or aggregated within bins or intervals. Again, the graphical display must not be obviously inconsistent with the choice of bandwidth or functional form specification used for the impact analysis. If a study uses a particular functional form for the outcome forcing variable relationship, then the study must show graphically that this functional form fits the scatter plot reasonably well. For instance, if a study uses a local linear regression for the impact analysis, then the scatter plot must show that the outcome forcing variable relationship is indeed reasonably linear within the chosen bandwidth. It is important to clarify that authors need only present the data they use for the estimates. For instance, when authors use only data within a local bandwidth for impact estimation, it would be acceptable for the graphical presentation to show only the data within the bandwidth and then ignore the data outside the bandwidth. Here's an example, a graph that displays a scatter plot of raw data and the fitted regression lines used to estimate the intervention impact at the cutoff score of 50. This graphical analysis would satisfy the criterion E of the functional form bandwidth standard. The functional form specification used for the impact analysis is consistent with the outcome forcing variable relationship shown here. In this example, the authors used a global linear regression estimated separately on either side of the cutoff, and the scatter plot suggests that this is indeed consistent and a reasonable choice of a functional form to these data. In contrast, here's a different graph that displays a scatter plot of the raw data and a fitted regression lines used to estimate the intervention impact at the cutoff score of 50. Again, a global linear regression model model specification was implemented on either side of the cutoff. However, in this example, the scatter plot suggests that this linear model specification is inconsistent with the functional form implied in the scatter plot. The scatter plot clearly indicates that the outcome forcing variable relationship is not linear and would be better reflected in a polynomial model specification. This graphical analysis would not satisfy criterion E of the functional form and bandwidth standard because the functional form specification used for the impact analysis is obviously inconsistent with the graphical display of the outcome and forcing variable relationship. Criterion F of the RDD standard requires that the relationship between the outcome and the forcing variable must not be constrained to be the same on both sides of the cutoff. In other words, the model specification used for the impact analysis must allow the outcome forcing variable relationship to vary on either side of the cutoff. For instance, a regression model where y is the outcome of interest, x is the forcing variable centered around the cutoff value, and t is a dummy variable indicator for treatment assignment, the inclusion of a multiplicative interaction term between x and t, shown as beta 3 on this slide, would appropriately allow the outcome forcing variable relationship to vary on either side of the cutoff. Conversely, a regression model omitting this interaction term that only included a main effect for the forcing variable, beta 1, and a main effect for the treatment assignment dummy indicator, beta 2, would not satisfy this criterion because such a model specification constrains the outcome forcing variable relationship to be the same on either side of the cutoff. The reason for this requirement is that the presence of an intervention is typically expected to change the relationship between the forcing variable and the outcome. So best practice is to allow for the relationship between the forcing variable to be different for the intervention and comparison groups. All right, it's time for your first knowledge check in this module. Authors of a study state that they calculated regression discontinuity design impacts using local linear regression using the static command robust, which provides robust standard errors. Impacts of the mentoring program were estimated using the following reduced form model. yi equals beta naught plus beta 1 times t times x plus beta 2 times GPA plus beta 3 times the interaction between the treatment and GPA plus beta p xi naught plus epsilon I, where yi is the outcome of interest, Tx is a dummy indicator for participating in the mentoring intervention program, or not. GPA is centered value for the forcing variable grade point average. Xi naught is the vector of covariates, including pretest measures of the outcome, and epsilon I is the error term. Does this study satisfy criterion A of the functional form and bandwidth standard? In other words, does the impact estimation model control for the forcing variable? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is A. Based on the information provided, criterion A of the functional form and bandwidth standard is satisfied because the impact of the intervention on the outcome was estimated using a statistical model that also controlled for the forcing variable. This is evidenced by the inclusion of the GPA forcing variable in the model specification. Therefore, this study would satisfy criterion A of the functional form and bandwidth standard. Welcome to Knowledge Check 2 for this module. Authors state that they calculated a regression discontinuity design impact using nonparametric methods to obtain a local polynomial regression, as proposed by Kalinoko, Cataneo, and Datunic in 2014. This is also called the robust CCT procedure. The authors provide a citation from the methodological literature that demonstrates the effectiveness of this procedure. Does this study satisfy criterion B of the functional form and bandwidth standard? That is, does this study use a local regression or a related non-parametric approach with impacts estimated in a justified bandwidth? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is A, based on the information provided. Criterion B of the functional form and bandwidth standard is satisfied because the authors used a non-parametric approach with impacts estimated using a justified bandwidth from the methodological literature. Therefore, this study would satisfy criterion B of the functional form and bandwidth standard. Time for the third knowledge check in this module. Authors state that they calculated RDD impacts using a global best fit quadratic regression model. The authors report the Bayesian information criterion, or the BIC, fit statistics for the quadratic regression model as well as 2.8, and for a cubic regression model as 3.9, where a lower BIC value represents a better model fit. No other fit statistics are reported in the study. Does this satisfy criterion C, best fit model estimation? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is B. Based on the information provided, criterion C of the RDD standard 4 is not satisfied. For studies that do not use local regression or a related non-parametric approach to estimate impacts within a justified bandwidth, to satisfy criterion C of the RDD standard 4, these studies must demonstrate that the functional form specification, or the best fit regression model, was a better fit to the data than at least two other functional forms. In this example, based on the information provided, the authors only demonstrated that the quadratic functional form was a better fit to the data than one other functional form, the cubic functional form. Thus, this study would not satisfy criterion C of the RDD standard 4, or also known as the functional form and bandwidth standard. All right, now it's time for your fourth knowledge check in this module. A study estimates a regression discontinuity design impact using a global best fit quadratic regression that was selected over a linear and cubic functional form using the AIC fit statistic. The authors report that the impact estimate from the best fit quadratic regression was negative 1.32, p less than 0.031. The impact estimate from the cubic regression was negative 1.75, p less than 0.018, and the impact estimate from the linear regression was negative 2.83, p less than 0.049. Does this study satisfy criterion D, the robustness criterion, of the functional form and bandwidth standard? Your choices are A, yes, and B, no. You may want to pause the video now to think about your answer. The correct answer is A. Based on the information provided, criterion D of the functional form and bandwidth standard is satisfied because the authors used a best fit global polynomial estimation strategy, and the authors demonstrate that the impact estimate has the same sign and statistical significance for the best fit functional form, as well as two additional functional forms. Therefore, this study would satisfy criterion D of the functional form and bandwidth standard. All right, time for knowledge check 5. A regression discontinuity design study will present the graph that I'll show you on the next slide. The authors reported that they used a linear regression within a justified bandwidth of negative 1 to 1, and that they allowed the relationship between the outcome and forcing variable to differ on either side of the cutoff. Based on this graph, does the study satisfy criterion E of the functional form and bandwidth standard? Your choices will be A, yes, or B, no. Okay, in this graph, the solid vertical line represents the cutoff, and the dashed line represents the functional form of the regression. Recall that the authors reported that they used a linear regression within a justified bandwidth ranging from -1 to 1, and they allowed the relationship between the outcome and the forcing variable to differ on either side of the cutoff. Again, based on this graph, does the study satisfy criterion B of the functional form and bandwidth standard? Your options are A, yes, or B, no. Again, you may want to pause the video now to think about your answer. The correct answer is A. Based on the graph provided, criterion E of the functional form and bandwidth standard is satisfied because the scatter plot of the outcome and forcing variable does not show an obvious inconsistency with the specified functional form within the bandwidth. So this study does provide a graphical analysis of an appropriate functional form specification. Now, these data are noisy, so it may not be clear that the slope of the best fit line in this plot was the very best functional form for this data. But a study should really only fail criterion E if the functional form and bandwidth standard should really only fail criterion E of the functional form and bandwidth standard if the data themselves are obviously inconsistent with a functional form and bandwidth choice. The data here are not obviously inconsistent with the functional form, so the study would meet criterion E. Generally, we want to give study authors the benefit of the doubt on this criterion, but if you're not sure, you can always raise the issue with your review team leadership. Time for knowledge check 6. The authors state that they calculated the RDD impacts using local linear regression within a bandwidth of 25 that was selected using the InVens and Kalyanorama 2012 plugin procedure. Impacts of the mentoring program were estimated using the following reduced form model, where yi equals beta 0 plus beta 1 times tx plus beta 2 times ps plus beta p times xi naught plus epsilon I, where yi is the outcome of interest, tx is a dummy indicator for participation in the reading intervention program, or not, ps is a normalized and centered value of the forcing variable placement score, xi naught is a vector of covariates, including pretest measures of the outcome, and epsilon I is the error term. So does this study satisfy criterion F, the unconstrained on both sides of the cutoff, of the functional form and bandwidth standard? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. B is the correct answer. Based on the information provided, criterion F of the functional form and bandwidth standard is not satisfied because the authors have constrained the outcome forcing variable relationship to be the same on either side of the cutoff. Because the model used to estimate impacts on the outcome did not include an interaction term between the program participation indicator and the forcing variable, the study does not satisfy criterion F of the functional form and bandwidth standard. Time for your final knowledge check of this module. A regression discontinuity design study satisfies RDD standard for criteria A, C, E, and F, but the study does not satisfy criteria B and D. The functional form and bandwidth standard. For the functional form and bandwidth standard, or RDD standard 4, does this study A, completely satisfy the standard, B, partially satisfy the standard, or C, does not satisfy the standard? You may want to pause the video now and look back to the requirements for completely, partially, or not satisfying the standard to consider your answer. B is the correct answer. The study partially satisfies the functional form and bandwidth standard because it satisfies criteria A, C, and E. To partially satisfy the standard, it's not necessary for the study to satisfy criteria D or F. This concludes our module on the WWC's 4th RDD standard, or the functional form and bandwidth standard. Let's review what we discussed in this module. We described the 6 criteria used to assess the standard. To completely satisfy the functional form and bandwidth standard, an RDD study must satisfy each of criteria A, B, D, E, and F, which all help to establish that appropriate methods were used to specify the bandwidth and functional form specification. To partially satisfy the standard, a study must satisfy criterion A and E, and must also satisfy either criterion B or criterion C. Otherwise, an RDD study would not satisfy the functional form and bandwidth standard. Recall that there are 5 total standards which determines a study's overall rating. You are now familiar with 4 of the 5 standards. For a study to receive a rating of meets WWC RDD standards without reservation, a study must completely satisfy the functional form and bandwidth standard. For a study to receive a rating of meets WWC RDD standards with reservations, a study must partially satisfy the functional form and bandwidth standard. A study that fails to satisfy the functional form and bandwidth standard will receive a rating of does not meet WWC RDD standards. The next module in the training series will focus on the WWC's 5th RDD standard, which is about specifically on how to review evidence from fuzzy RDD studies. For the next module, you will watch a webinar produced by the WWC that discusses the standards for reviewing evidence for these unique types of regression discontinuity designs.